Hello, hello. Good morning. Okay. Can hear me, yeah? No problem, yeah?
Yeah.
Yep, yep. Okay. Yeah, so we are back to the topic of electrochemistry. Yeah, okay. So we were up to 5.7 last time. Okay. So before we keep going, okay, let me just have a quick review of what we learned last time. Yeah, okay. Okay, so the main point about electrochemistry is we involve electricity. We use the energy from electricity. So this is our setup. Okay, so we have the power supply and then we have the electrodes. Okay, so normally it's inert electrodes. Normally we can use carbon or platinum. And then the positive terminal is called anode, and then negative terminal is called cathode, and then we have the electrolyte. Okay, so why we have this electrolysis is to get back, okay, the elements. Okay, get back the elements. Okay, example, let's say we have sodium ion. We want to get back to the sodium metal. Chloride ion, we want to get back to the chlorine element. Okay, and then aluminium ion, get back to the aluminium metal. Yeah, okay. Return back to the metal. And then example, oxygen ion, get back to oxygen gas. Okay, elements. So our main objective, get back to elements. Okay, but the products, okay, the products will be different, depend on our setup. Okay, so let's say we change the electrode, the product could be different. We change the electrolyte, the product could be different. Let's say we melt, okay? We melt the sodium chloride, okay? We melt the sodium chloride, the product will be different. Or we have a sodium chloride solution, okay? So this one, we will have two ions only, sodium ion and chloride ion. So this one, we will have sodium ion, chloride ion, and then hydrogen ion and hydroxide ion that is coming from the water. Okay, so it depends on the setup, the conditions. Okay, we will be getting different products. Okay, so last week we discussed all the details. Okay, yeah, okay. So yeah. So what happened at the electrode? We will have um oxidation and reduction. Okay, so if we have a positive ion, it will reduce back to zero oxidation state. Okay, when we have negative ion, okay, so this one is reduced. When we have negative ion, it will oxidize back to the zero oxidation state. Okay, yeah, and then uh anode is always oxidation, cathode is always reduction. Okay, yep. So we look at this example here. Okay, so lead, we have lead bromide. So we have lead ion and bromide ion. Okay, so this is molten, so only two ions. Okay, so lead will come here. Okay, 2 plus, go to the negative electrode, attracted, and then bromide will be going to the positive, the electrode. Okay, and then the positive ion will be reduced to return back to the metal, and then the negative ion will be oxidized, okay, to return back to the element. Okay, yeah, so as mentioned before, bromine is always Br2, so we will balance it out, okay, with two bromide and two electrons. Okay, so we will get the bromine gas here. So we'll see the uh, bromine vapor, and then here we'll see the lead metal deposited on the electrode. Okay. Yeah. Yeah. So here we have more examples. Okay. So how to uh uh create the ionic half equations, and then aluminum oxide. So as we mentioned before, aluminum is a very useful metal. Okay. But we always start with aluminum 3 plus. So that's why we do the electrolysis to get the aluminum metal. Yeah, so this is the process that we learn about. Okay, yeah. Okay, aqueous solutions. So as I mentioned before, when we have water, the products will be different. Yeah, okay. So this is a summary of all the different products under different conditions. Okay, so if we have molten, okay, so what will be the products if we have still sodium chloride, but if we have concentrated sodium chloride, okay, what are the products? Molten, okay. So we will come to this later, more examples, okay. Yeah. So it will depend on the reactivity series as well, okay, and also the concentration. Okay. Yeah. So if we are changing the electrode, there will be some effects as well. We mentioned last time. Okay, so later we'll see more example. Okay, so we look at fuel cell, which is a environmental friendly way of producing the electricity. Okay, using the fuel cell. Okay, advantages and disadvantages. Okay, so next we come to the next topic. Okay, which is talking about electroplating. Okay, so it's another use case. Okay, another application of the um electrolysis. Okay, so now what we are trying to do is uh we are trying to coat a metal with a thin layer of another metal. Okay, so let's say we have a metal spoon. Okay, we have a metal spoon. Okay, we want to coat the surface another metal. Okay, so this is what we call electroplating. Okay, just a thin layer. So why we do that? To improve the appearance, so make it more shiny, something like that. Prevent corrosion. Okay, example, prevent rusting. Okay, so let's say we have iron spoon, we have a steel spoon, so maybe it can rust easily. But if we coat with another layer of metal, it will not rust. Okay. Yeah. Okay. So this is our setup, how we set it up. Okay. There are some key points here. Okay. So let's say we want to coat this spoon. Okay. We want to coating this spoon with silver. Okay. So there are a few things we need to pay attention. So first, plating metal as the anode. Okay, so what we want to plate with silver. The silver we must put at anode. Okay, the object to be plated as the cathode. So the spoon we must put at the cathode. Okay, and then the aqueous solution must be having the silver. Yeah, so we have the silver nitrate. Okay, so must be having the silver. Okay, so what is happening here? So here we want to coating with the silver. Okay. So this is negative. This is positive. So here what happened? The silver ion will be attracted to here. Okay. And also um uh hydrogen ion. Okay. So we have these two choice. Which one will react? Okay. As we mentioned before. Okay. Yes. Let me copy this. Okay, how we determine which one will react. Okay, so we'll look at the reactivity series. Okay, so basically the one that is, so we have hydrogen and then we have silver. Okay, so always the lower one. So this is the lower one. The lower one will react. Okay, less reactive in the reactivity series. Less reactive. The lower one will react. Okay, so between these two, okay, silver will be reacting. Okay, so what happened to silver? So silver will add one electron, okay, to become silver metal, and then the silver metal will be coating on the surface of the spoon. Okay, so that's the concept. Okay, and then what happened to the other side? So here we have the uh, nitrate ion, which is negative, will be attracted here, and then we have the hydroxide ion. Okay, and then we also have the silver metal. Okay, silver metal, which is the electron. Okay, so out of these three, the silver metal is the one that will react. Okay, always the case. If we take a silver electrode, that is the one that will react. Okay, so what happened here? Silver metal will turn to silver ion. Yeah, okay. So this ion, this electron will go to the circuit, okay, and then it can be used here. Okay, and then this silver ion, it will go into the solution and then it will be reacted here. Okay, so we will not use up this silver ion. So we keep on having a fresh supply of the silver ion. So that is how it happens. So it depends how thick we want the plating. We will leave it there for different amount of time. Yeah, okay. So at the cathode, okay, this is what happened. Yeah, okay. Silver ion turn to silver metal. Okay, at the anode, okay, this is what happened. Silver metal turn to silver ion. Okay, so this is how we set up the electroplating. Okay, yep, sample question, we can take a look. What is meant by electrolysis is the decomposition of ionic compound. So we take any ionic compound, example, sodium chloride, and then when molten or aqueous solution by the passage of electric current. Okay, so what we means by decomposition, this ionic compound, we will break it down, okay, into the ions, and then the ions return back to the element. Okay, so that's what we mean by decomposition. Okay, yes. Okay, next, complete the table below. Okay, yeah, so if we are given these three situation here, what will be the product? Okay, so we will go through one by one. Okay, so lead bromide is PbBr2. Okay, so PbBr2. So okay, so we can analyze together. Okay, what we expect to happen. Okay, so we have the like this. Okay. Okay. Positive electrode and negative electrode. And then we have Pb2 plus and then Br negative 1. Okay. So Pb2 plus, okay, will come here. Okay. And then the Br negative will come here. Okay. So Pb2 plus, it will add 2 electrons to return back to the uh, Pb0. Okay. So which will give us the so the negative will be cathode. Okay. The positive will be anode. Yes. Okay. So at the cathode, we will have the lead metal. Yeah. Okay. So here, this bromide, what happened? It will turn to bromine. Okay. Bromine gas, zero oxidation state. Okay. So basically, it will lose 2 electrons. Yeah. Okay. So we will have the bromine gas. at the anode. Yeah, okay. Concentrated sodium chloride. Okay, concentrated sodium chloride. Okay, so again, we can analyze. Okay, okay, sodium chloride, sodium chloride. Okay, two ion, aqueous solution. Okay, so means we have another two ions which is coming from water. Okay, um, hydrogen ion and hydroxide. Okay, so again, like this. Yeah. So if you know how to analyze, then it will be very clear what is the product. Okay, so now it will be attracted sodium plus hydrogen plus. Okay, so okay, let us take this reactivity series. Okay, okay, bring it here. Okay, reactivity series. We have sodium and hydrogen. Okay, so sodium and hydrogen. Yeah, sodium plus hydrogen plus. Okay, as I mentioned before, always the lower one will react, the less reactive one will react. Okay, so here the H plus is the one that will react. Okay, so it will be reduced. Okay, like this. Yes. Okay, so we'll get hydrogen gas at the cathode. Okay, hydrogen gas. Okay, and then here we have these two. Okay, positive here. Okay, hydrogen ion and chloride ion. Okay, so now which one will react? It depends whether it is concentrated or not. Okay, so if it is dilute, the hydrogen will react. Sorry, the hydroxide will react. Okay, if concentrated, okay, concentrated means we have a lot of chloride. The chloride will react. Okay, concentrated, the chloride will react. Okay, um, like this, chloride. Okay, and then um, it will lose two electrons, like this. Okay, uh, yes. Okay, so end up to be like this. So we're going to have chlorine gas. Chlorine gas, okay, on this side. Okay, next, dilute sulfuric acid. Okay, so dilute sulfuric acid. Okay, what happened? So sulfuric acid is like this H2SO4. This is sulfuric acid. Okay, so which means we have H plus SO4 2 negative. Okay, and then we also have water. Okay, water H plus hydroxide. Okay, now coming back to our setup here. Okay, positive, negative. Okay, anode, cathode. Okay. Cathode, we will attract these two. H plus, they are the same. So basically no choice. The H plus will react. Okay. So the H plus will be adding two electrons to get the hydrogen gas. Okay. So now our product will be hydrogen gas. Okay. Hydrogen gas. Okay. So okay. And then now here we have sulfate, okay, and the hydroxide. Okay. Yeah. So between these two, always the hydroxide will react. Okay, because hydroxide is the one that is less stable. Okay, So the sulfate is very, very stable. Okay, so it does not react. Okay. Okay. Now, um, okay. So how do we do the equation? Okay, half ionic equation. So we start with OH. Okay, hydroxide like this. Okay. So now, um, okay. So on the other side, we know that our product will be uh oxygen gas. Okay, oxygen gas must be always O2. Okay, must be always O2. So what we can do, we can put 2 here. Okay, so 2 here. So if we have 2 hydrogen here, so how do we balance the hydrogen? We add water here, H2O. Yeah, like this. Okay, but here now we have 3 oxygen. So now how do we balance it? Okay, so now we need to make it like this. Okay, we need to make it 4 to balance it. Okay, so now we have 4 hydrogen. So this is 2 here, 2, 2. So this is 4 hydrogen, 4 oxygen. Okay, no problem. So now we need to balance the charge. So here is 4 negative charge. So here we need to balance with 4 electrons. Okay, so this is how we work out the half equation. So it looks like this. So for the half equation, if you find like very confusing to to work it out by yourself, you memorize it. Yeah. So you if it's very confusing. Okay, so now here the product will be oxygen gas. So that's how we do it. We can work it out step by step. Yeah, so basically we can do that. Okay, so if you find it very difficult to work out by yourself, okay, so what we do, okay, we memorize this table. Yeah, okay. So if we memorize this table, we more or less have everything. Okay, we have all the information for the exam. Okay, but if you can work it out, it is the best. Okay, so you don't need to memorize it. Okay, next. Okay, yep. So this is done. Okay, so now we will come back to the exam style question. Okay, exam style question is the similar kind of question. Yeah. Okay. So now we will work it out one by one by ourselves. Okay. Yeah. So this one is basically the hardest topic in the IGCSE chemistry. Okay. So if you understand this one, you are totally fine. Okay. So you you basically can score very well for the chemistry. Okay, but it can be a little bit confusing. Okay, we can go slowly. Okay, so now again, we need to work out the product at the anode and the cathode. Okay, so molten potassium bromide. Okay, so again, we will analyze like this. Okay, as usual. Okay, potassium bromide is KBr. Yeah, so we have these two ions. Okay, positive anode, negative cathode. Okay, so the potassium, it will come here and then it will uh, return back. Okay, positive charge, it will return back. Okay, receive 1 electron, reduce to potassium metal. Okay, so basically what we expect to get here is the um okay, yes, okay, what we expect here is the potassium metal. Potassium metal. Yeah, okay, so we can check the answer here. Potassium. Yeah. Okay, so at the anode, we have this bromide. Okay, so now, again, we will remove the charge. Okay, how we remove the charge? We remove the electron. Okay, so we'll get Br2, so we need to remove two electrons. So this is 2. So we'll get the bromine. Okay, we'll get the bromine. Yes. Okay. Yes. So our answer is bromine here. Okay. Yeah. Okay. Yep. So basically, I will go through many, many examples like this. If you want to try by yourself, also can, no problem. Okay. Next one. Um. Okay. Eh, Next one, we have molten sodium chloride. Okay, molten sodium chloride. So means we have Na plus Cl negative. Okay, so now we try again. Okay, another one. Okay, okay, positive, anode, negative, cathode. Okay, so the sodium ion will come to the negative electrode. Okay, so again, we can see it's very similar situation. Okay, so we will add one electron to return back to the sodium metal. Okay, discharge. Sodium, okay, metal. Okay, checking our answer. Sodium. Okay, next here, same thing. Chloride will be attracted to the positive electrode. Okay, um, wait. Okay, so chloride, we need to discharge, so we need to remove electrons. So remove electrons means plus electron on the other side, chlorine 2. So 2 electron here, 2. Okay, so we'll get the chlorine gas. Chlorine gas. Okay, so this is how we work out the products. Yeah, so now you slowly familiar with the steps. Okay, so how to do it step by step. Okay. Okay, next. Concentrated aqueous sodium chloride. Okay, so now we can see the difference between molten and concentrated. Okay, so concentrated, we still have the sodium chloride, but now it's aqueous solution. We also have the hydrogen ion and hydroxide ion. Okay, so now we have 4 ions. Okay, 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 positive, anode, negative, cathode. Okay, now positive will come to here, sodium, hydrogen. Okay, so as mentioned before, just now, okay, reactivity series. Okay, yeah, okay, reactivity series, sodium, okay, hydrogen. Always the lower one will react, always. Okay, so here, the hydrogen, it will be discharge. Okay, discharge. Okay, adding electron. Okay, but hydrogen is H2, so we need to make it 2 2 like this. Okay, so now here, instead of sodium metal, our product change. Okay, so when we change from molten to concentrated, our product is also changing. Okay, so here we have hydrogen gas. Yep. Okay. Uh, yeah. Next. Okay, so here we have uh these two. Okay, chloride and hydroxide. Yes. Which one will react will depend whether it's concentrated or not. Okay, so if it is concentrated, then we will choose chloride. Okay, because there's a lot of chloride there. Okay, chloride. Okay, and then it will turn to chlorine. So we will lose two electrons here. So two electrons. So here, like this. Okay. Um, yes. So our product will be chlorine gas. Okay. Chlorine. Um, Chlorine gas. Yeah. Okay. So we can see here, this part, the product change. This part, the product, no change. Okay. So it depends on the situation. Okay, so this one, iodine and lead. Okay, so what happened here, how we can get iodine and lead, okay, will be like this. Um, okay, um, yes, okay, iodine and lead, in order to get iodine and lead as the product, okay, what we must have must be this, okay, molten lead iodide. Okay, it must be molten lead iodide. Okay, so what happened here? Okay, so if we have molten lead iodide, okay, so means we have Pb2 plus and then iodide. Okay, positive, negative, cathode, okay, anode. Okay, um, so anode here, cathode here will be attracting Pb2 plus. So adding two electrons, so we get the lead metal. Okay, so that's how we get it. Okay, and then this one, iodide will be remove electrons. Okay, to get iodine. Yep, and then here too. Okay, so as I mentioned before, iodide, it must be remove two electron, minus electron to get the iodine. Okay, it should be like this. Okay, but in chemistry, we don't do minus electron. Okay, because sometimes it's like very confusing, very easy to make mistake. We don't do minus electron. We always do plus electron. So we move it to the other side. So we always have it like this. Yeah, okay. So although we know that it's actually minus electron, but we will write the equation like this. Okay. Next. Okay, so another exam type question here. So as you can see, these are the type of questions that we will get. Okay, aqueous lithium chloride is electrolyzed using the apparatus opposite. Okay, so here we will label the anode. The positive one is the anode. Okay, the cathode will be the negative one. Cathode. Okay, and then electrolyte. Yeah, so there should be. So this is the electrolyte. Okay. Um, aqueous lithium chloride. Okay. So aqueous lithium chloride. So means the electrolyte. Um, hold on. Okay. So means here it will be lithium chloride. Lithium positive one, chloride negative one. Okay. Lithium is group one. Yeah. Okay. So it's group one on the periodic table. So it will form plus one charge. So chloride is always -1. Okay. Um, yep. Okay. So what it means by aqueous? Okay. Yes. Okay, so just now, the anode is the positive electrode, cathode is negative electrode. Electrolyte will be the liquid in the beaker. Okay, so now what it means by aqueous? So aqueous means it's dissolved in water. Okay, so this lithium chloride is dissolved in water. Explain why aqueous lithium chloride is able to conduct electricity. Okay, so why it can conduct electricity? Because we have these ions. Okay, so these ions that can move around. Okay, yes, ions that are moving carry the charge. Okay. Okay, next. Question 3. Aluminium is attracted by electrolysis from its main ore. Name the main ore of aluminium from which aluminium is extracted. Okay, so we have learned this before. The um, aluminium ore. Okay. Uh, yes. Okay, hold on. Yes, aluminium ore. This one. Okay. So the aluminium ore is the bauxite. Yeah, it looks like this. Okay. It looks nothing like a metal. Okay. So um we need to go through the electrolysis to get the shiny metal. Okay. Next. Okay. So we need this. Okay. Reactivity series. Yeah, um to answer this question. Okay. So name the ore. Okay. So we just mentioned that is bauxite. Yes. Okay. And then use your knowledge of the reactivity series to explain why aluminum is not extracted by reduction of oxide using carbon. Okay. So yeah, why we cannot use carbon? Okay. So we'll look at the reactivity series. Okay. Reactivity series. So we can see aluminum here and then carbon. Aluminum. Okay. And then carbon. Okay. So aluminum, okay, so carbon we can use for zinc, we can use for iron and so on. Okay, so we can use carbon to take iron 3 plus to iron 0. Okay, no problem. Zinc 2 plus to zinc 0, no problem. Okay, but carbon aluminum cannot. Okay, because aluminum is higher. If it is higher, it cannot use carbon. Okay. Yeah. So aluminum we must use electrolysis. Okay. So for aluminum, we must use electrolysis to return it back to the aluminum metal. Okay. Yeah. So that's the point. Okay. Aluminum is above carbon in the reactivity series. Okay. Next. Okay, so here we need to fill in the blanks. Okay. Yeah. So the first one, electrolysis. Yeah. Okay. So electrolysis is the process in which what are we trying to do? In which the electrolyte is decomposed. Okay. So inside the electrolyte will be ionic compound. Yeah. Okay. So the products of the decomposition are formed at the will be formed at the electrodes. Okay. So the positive electrode, what is the positive electrode? It is the anode. Okay. And the negative electrode is the cathode. Okay. Next. What is electroplating? Electroplating means we take a spoon. Okay. We want to cover another layer. Okay. Covering a metal object with a thin layer of another metal. Okay, so one of the reason for electroplating, why we have electroplating, is to improve appearance. Okay, make it more shiny. Okay, and then another is to resist corrosion. Okay, so make sure it does not corrode, it does not rust. Okay, next. Okay, a student wants to electroplate a knife with nickel. What the student should use? Okay, now a knife. Okay, so we must set up like this. Okay, so we must put the knife, okay, at the cathode. Okay, and then we must put here the anode. We must put the nickel. Yeah, okay. So we must set up like this. And then the electrolyte must be um nickel. Nickel ion. Okay, nickel ion. Okay. So it could be nickel uh nitrate or nickel sulfate. Okay, so either way is fine. Yeah. Yep. So that will be the electrolyte. Okay. So A, the anode. Yeah. So the anode should be nickel. The electrolyte, okay, nickel nitrate. Okay. Or any solution with nickel. Okay. Mostly we will use nickel nitrate because it's soluble. Okay. And then uh the knife. Okay. So the knife we will put at the cathode. Okay. So what happened? The nickel ion will come here. Okay. So the nickel ion will be attracted to the knife and then it will discharge to form the nickel metal and then coating on the knife. Okay. So here, what happened? The nickel metal, it will um, remove electron to form nickel ions. Yes. Okay. So that's how it happened. Okay, next. Okay. A student carry out electrolysis of concentrated potassium iodide. Okay. Concentrated aqueous solution of potassium iodide. Okay, so now we'll try to analyze. Okay, potassium iodide is potassium ion, iodide ion. Yeah, okay. So it's like this. Okay. Okay. Cathode. Okay. Anode. Yep. So concentrated aqueous solution, we will have hydrogen ion and hydroxide. Yeah. So now this cathode, it will attract potassium and hydrogen. Yeah, okay. So it will attract these two. Okay. So now we have potassium and hydrogen. Okay. So let's take a look. Okay. Reactivity series. So if we look at the reactivity series, okay, potassium is here, hydrogen is here. Okay. So always we will take the lower one. Okay. So hydrogen will react. Okay. So like this. Okay, adding two electrons. Okay, so we'll get the H2 gas. Okay. And then here, negative electrode will attract the no, this anode is positive. Okay, so positive will attract the negative. Okay. So hydroxide, okay, and iodide. Okay. So because this is concentrated, it has a lot of iodide. So iodide is the one that will react. Okay. So 2 iodide, okay, again, it will lose 2 electrons, okay, to form the iodine. Okay, so now we already have the product on both sides. Yeah, okay, so we already have the product. Name the product at the anode. Anode will be this iodine. Okay, yes. Okay, write the half ionic equation for the reaction occurring at the cathode. So cathode will be this one. Okay, so this will be the ionic equation. Yes. Okay, next. State the type of reaction occurring at the anode. So the anode is always oxidation, okay? Losing electrons. Cathode is always reduction. So reduction is adding electron. Okay, so our answer is oxidation. Okay, next. Name the solution left in the beaker when the electrolysis has finished. Okay, so now we react these two, iodide and the hydrogen ion. Okay, what is left in the solution will be this. Okay, yeah, the one that is not react, potassium hydroxide. Okay, so our answer will be potassium hydroxide. Okay, yeah, like this. Okay, next. Name the type of particle responsible for the conduction of electricity in the wire. Okay, so in the wire, it will be the electrons. Okay, the electrons conducting the electricity. Okay, yeah, okay. The type of particle responsible for the conduction of electricity in the electrolytes. So inside the electrolyte, it will be the ions. Yeah, okay. So it will be these ions that are conducting the electricity. Okay, yes. Okay, ions. Okay, next. Yeah, so another question whereby we need to work out the um products. Okay, so again, we can analyze. Yeah, we can analyze one by one. Okay, so if you know how to analyze all the situation, so you will be able to work out the products. Okay, so first one, aqueous copper sulfate. Aqueous means have water. So we have copper 2 plus, and then we have sulfate, and then we also have the hydrogen ion and hydroxide ion from the water. Okay, so now this is our setup. Okay, anode. Okay, and then cathode. Okay, so it doesn't matter which way you put, as long as one side is positive, one side is negative. Okay, so the negative will attract the positive, copper 2 plus, H plus. Okay, and then the other side will attract the negative, positive will attract the negative. So sulfate, okay, and hydroxide. Okay, so let's look at our reactivity series. So we have copper and hydrogen. Okay, so we have hydrogen and copper. Okay, H plus, copper 2 plus. Okay, so as we mentioned, the lower one will react. Always the lower one will react. So now the copper will add 2 electrons to form copper metal. Okay, so at the cathode, we will have copper metal. Yeah, okay. And then at the anode, we have sulfate and hydroxide. Always hydroxide will be selected, always. Sulfate is very stable. So our equation will be like this. Okay, for hydroxide, and then oxygen gas, and then 2 water, and 4 electrons. Okay, So our product will be oxygen gas. Okay, oxygen. Yeah, okay. So we check our answer. Oxygen at the anode, copper at the cathode. Okay, so that's how we work it out. Okay, second one. Okay, concentrated aqueous lithium bromide. Okay, so lithium is group 1, so the ion is always +1. Bromine is group 7, is always -1. Okay, aqueous means we have water like this. Yeah, okay. So we have these 4 ions. Okay, so again, we set up our analysis. Okay, like this. Okay, positive, anode, okay, negative, cathode. Okay. Um, Negative attract positive, lithium and hydrogen. Okay. And then here it will be bromide, okay, and hydroxide. Okay. Negative attract positive, positive attract negative. Okay. Okay, now we'll look at this side, lithium and hydrogen. Okay, so we can see here, lithium is here. Yeah, okay, hydrogen is here. So in this case, the lower one will react. The hydrogen will react. Okay, yes. So hydrogen, okay, as usual, 2 hydrogen plus 2 electron will turn to hydrogen gas. Okay, so here we have hydrogen. Yes. Okay. So the gas we can put or not put is fine. Okay. So the important part is the hydrogen. Okay. And then on the other side, we have bromide and hydroxide. Okay. So we see here this is concentrated. So if it is concentrated, we have lots of bromide. So bromide is the one that will react. Okay. So as usual, it will remove 2 electrons to form the bromine. Yeah, okay. So here our product will be bromine. Yes. Bromine, gas. Okay. Yes. Bromine and hydrogen. Okay. So this is how we work out our product. Okay, next. Okay, dilute aqueous sodium chloride. Okay. So here we have sodium chloride. Okay, sodium group 1, so +1, chloride group 7, -1, and then from water, hydrogen and hydroxide. Okay. Okay, as usual. Okay, positive anode. Okay, and then negative cathode. Okay. Um Next. Okay. So what do we do? So the negative will attract the positive. Okay. Sodium and hydrogen. Okay. And then next, the positive will attract negative. Chloride and hydroxide. Yeah. Okay. Now, again, sodium and hydrogen, we see here, sodium here, okay, sodium here, hydrogen here, always the lower one will react. So the hydrogen will react, okay, plus 2 electrons to form the hydrogen gas, okay. So here our product will be the hydrogen gas. Okay, on the other side, okay, so this is dilute. Okay, so if concentrated, we will choose chloride. If dilute, we will choose hydroxide. Okay, because there is less chloride. Okay, so hydroxide, as usual. Okay, so how we write the um, half equation. Okay, so we start with the 4 hydroxide, okay, oxygen and water and 4 electrons. So our product will be oxygen gas. Okay, yep. So checking answer. Okay, oxygen and hydrogen. Okay, straightforward. Okay, next. Okay, describe how the color of aqueous copper sulfate solution changes when it undergoes electrolysis using carbon graphite electrodes. Okay, yeah. So this is the situation if we change the electrode. Okay, so what happened if we have different electrodes? Okay, wait. Okay, so now let's take a look. Okay, copper sulfate solution. Okay, so this one, copper sulfate solution. Okay, so we will have 4 ions. Okay, copper sulfate solution. So we will have Cu2 plus, and then we will have sulfate, and then again from water, um, like this. Okay, hydrogen and hydroxide. Okay, so we will set up. Okay, okay, positive anode. Okay, negative cathode. Okay, so now negative will attract positive. So copper 2 plus. Okay, and then H plus. Okay, so now looking at the reactivity series. Okay, what can we see at the reactivity series? Like this. Okay, so we can see hydrogen, copper. Okay, so the lower one will react. Okay, so copper will be adding 2 electrons to form copper metal. Okay, so this is our product here. Okay, yep. And then here, we have, so this one is carbon. Okay, carbon electrode, carbon electrode. Okay, so yeah, this carbon, carbon. Okay, so here we have the negative ions. Okay, so sulfate. Okay, hydroxide. Okay, as mentioned before, sulfate is very stable, so hydroxide is the one that will react always. Okay, so for hydroxide form oxygen, form water, and then 4 electrons. Okay, so the product will be oxygen gas. Okay, and then you see here the copper ion, it keep using up. Okay, we keep using the copper ion to turn to copper metal. So this one is getting less and less. Okay, so this copper ion, it has the blue color. It caused the solution to be blue color. Okay, so now we are asking how the color is changes. So we are saying that this copper ion is less and less, so the color will be fading. Yeah, fading to until it is colorless when all the copper is used up. Okay, so that's what we expect to happen. Okay, like this. Okay, from blue to colorless, it's fading. Okay, so now if we have exactly the same setup, okay, so this one, okay, is carbon electrode. Okay, exactly the same setup. The only thing we changing is using copper electrode. Yeah, okay. So that's the only thing that we change. Then what happened if we have a copper electrode? Okay, like this. Okay, anode. And then this one is the cathode. Okay, so now here we still have copper 2 plus and then hydrogen. Okay, so now this one is Cu, copper electrode. This is Cu, copper electrode. Okay, so if we change the electrode, what will happen? Okay, like this. Okay, like this. Okay. Um. Okay. So if we change the electrode, here we still have sulfate. Okay, and then hydroxide, and then we have a new thing. We also have copper here. So we have three things to choose from. Okay. So here we have okay. So this is 1, 2, 1, 2. Okay. So this is 1, 2. Here we have 1, 2, 3. Okay. So that's the difference. Okay. We have three things to choose from. Okay. So we'll look at this first. So the copper is lower. Okay. So again, the copper will react. So this one plus 2 electrons to get the copper metal. No problem. This is still the same. Okay. Okay. So same copper, copper. Okay. So the product is the same. But here, this one will be different. Okay. So here we will be choosing the copper. Okay. So this is the difference when we use the copper electrode. Okay. So now the copper, what it will do, the copper, it will lose 2 electrons to become the copper 2 plus. Yeah. Okay. Like this. Yes. Okay. So this is the one that happened. Okay. So here our product will be this copper ion. Yeah. Okay. Um, yes. Okay, so let me just highlight all of the products. Okay, with a different color. Okay, maybe, okay, this. Okay, so we'll look at the product. So this one, the product is oxygen. This one, the product is copper. And then this one, the product is still copper here. But here the product is copper 2 plus. Yeah, okay. So now we have different product. So here is still same copper, copper, but here is oxygen. Here, this is copper 2 plus. Okay. So this is the effect when we change the electrode from carbon to copper. Okay. The change that occur at the anode. So at the anode, we have this um copper metal oxidized to copper ion. Yes. Okay. So what we see? Yes. At the copper anode, it goes into solution at Cu2 plus. Cu metal, it turns to Cu2 plus. Okay. Observation made at the aqueous solution. So just now at this situation, we are saying that the copper 2 plus is less and less. So the color will turn to colorless. Okay. From blue to colorless for this situation. Okay. But for here, what happened? We are using up this copper 2 plus, but now we are making new ones. Okay. So it is replenish. Okay. So the copper 2 plus is constantly replenished. So it remain as blue color. Okay. So this one, it will be turned to colors. This one, it will remain blue color. Okay. So that's the difference when we change the electrode. Okay. Yeah. No change in color. It stays blue. Okay. Yeah. So with this, we finish all. Yeah. Yes. So we finish all the questions and all the notes for this unit 5 of chemistry. Okay. Unit 5 electrochemistry. Okay. Yep. Okay. So now what we can do, we can look at the workbook. Yeah, we can try to finish the workbook also. Yeah, so if we finish the workbook, then we finish everything, this topic. Okay? Yeah. Okay. So let's take a look at the workbook questions. Okay. Okay. So first, we can take a look. Um, okay, so here we have result of testing a number of solid and liquid substances to see if they conduct electric current. Okay. So electrode used were made from platinum in each case. Yeah. Okay. So each one the electrode is platinum, so it is inert electrode. Okay. So okay. So we will go through the questions one by one. Which of the substrate are electrolyte? Yeah, which one is electrolyte? Okay, so we'll see one by one. Okay. Um okay, you see, this one, hydrogen and chlorine. As soon as we seen the product is hydrogen, okay, so means it is aqueous. Yeah, this one will be aqueous. So this liquid is solution, aqueous. And then silvery metal and green vapor, okay, silvery metal and green vapor. If we see like this, okay, so it's very possible. At this moment, we can say it could be aqueous or molten. Okay, both possible. Okay, next. This one, none, nothing. So this one we cannot conclude yet. Okay. So hydrogen and oxygen. Okay. Again, as soon as we see hydrogen, this will be aqueous. Yeah. Okay. This one, nothing, we can't say. Okay, it does not produce anything. Okay, pink, brown matter, and oxygen. Okay, so again, this one could be um aqueous or molten. Okay, so both could be possible. Okay, now we have concluded that T, U, W, Z. Okay, because they produce some kind of products, so means electrolysis happen. Electrolysis happen, so means these are all electrolytes. They are all electrolytes. Okay, so our answer for A will be okay. GUWZ. Yeah, okay. Okay, next. Which of these substance T to Z may be metals? Okay. So which one could be metal? Okay. A what do we think? Okay. So our answer will be this. Okay. Because they can conduct electricity. Yeah. Okay. So you see, this one, they can undergo electrolysis. Okay. So remember, if they can undergo electrolysis, they must be ionic compound. Yeah. Okay. So this one will be ionic compound. Okay. This one will be ionic compound. If it can happen electrolysis, it must be ionic compound. Okay, ionic compound. Okay, so this one also ionic compound. Okay, so if we want metals, okay, it's left these three. 1, 2, 3. Okay, so metal is conduct, okay, both solid and liquid. Both solid and liquid, it can conduct. That is metal. Okay, so our answer will be XY. XY will be metal. Okay, okay, hold on. Yes. Okay, so this one does not conduct, is not metal. So this one, our answer will be X and Y. Yeah, okay, X and Y. Okay, next. Okay, which of these substance may be molten sodium chloride? Okay, molten sodium chloride. Okay, so our answer, it will be U. Okay, our answer will be U. Why? Okay, our answer is U because it produces a metal. Okay, so when we produce a metal, it will be molten. Yeah, for the aqueous, it's always produce hydrogen. Yeah, always produce hydrogen. That is aqueous. If we produce metal, most likely it is molten. Yeah, so sodium chloride is U. Okay, next. Okay, maybe mercury. Okay, maybe mercury. Our answer is X. Okay, our answer is X. Okay, why? Because it's liquid. Okay, it's metal and then it is liquid at room temperature. So this must be mercury. So mercury have these characteristics. Okay, mercury is a liquid at room temperature, but it is still metal. Okay, so our answer is X. Okay, next. Okay, which one may be sugar solution? Okay, which one may be sugar solution? Okay, a our answer will be V. Okay, our answer will be V because sugar, okay, is covalent. Yeah, okay, it's covalent compound, so it does not conduct electricity. Yeah, so our answer will be V. Okay, next. Yeah, so next answer is V. Okay, okay. FG. Okay, what could be W? Okay, so what is W? Okay, let's take a look. Okay, so this one is a aqueous solution producing hydrogen and oxygen. Okay, so this one should be any dilute acid, any dilute acid or dilute alkali. Okay, yes. Okay, why is that? Okay, so let me explain. Okay, so let's say we have dilute acid. Let's say we have sulfuric acid. Yeah, okay. Dilute alkali, let's say we have sodium hydroxide. Okay, so our product will be hydrogen and oxygen. Okay, let me show why. Okay, okay. So let's say we have dilute acid. Okay, H2SO4. And then we have another situation is, okay, sodium hydroxide. Okay, so we are saying that okay, so let me just set up everything. Okay, okay, positive anode, okay, negative cathode, okay, positive anode, okay, negative cathode. Okay, so what ions we have? So we have H plus sulfate. Okay, so this one we have sodium plus and then hydroxide like this. And then here we have from water H plus and hydroxide. And then here we have water H plus and hydroxide. Okay, so now we will look at this cathode. It will attract H plus, H plus. Okay, so no choice. This one, both will react. So H plus plus two electrons, it turns to um, hydrogen gas. Okay, and then here it will attract sulfate. Okay, and hydroxide. Okay, as usual, hydroxide will react. Sulfate is too stable. So as mentioned before, hydroxide will turn to oxygen gas, water, okay, plus 4 electrons. So the product will be oxygen and hydrogen. Yeah, okay. So what we mentioned here, the product will be hydrogen, oxygen. Okay, hydrogen, oxygen. Okay, so here, similar situation. So we have sodium plus, hydrogen plus. So as mentioned before, okay, sodium is high on the reactivity series. Okay, so as we mentioned before, a reactivity series. Okay, here. Okay. Uh, yes. Okay, so let me put here. Okay, so we can see here sodium, hydrogen. Okay, so sodium is high on the reactivity series, so hydrogen will react. Okay, so here two hydrogen plus two electron turn to hydrogen gas. Okay, so this is our product here. And then here we have, okay, hydroxide, hydroxide. Okay, so they are the same, both will react again for hydroxide and then turn to oxygen and then turn to water for electrons. Okay, so again, our product, oxygen and hydrogen. Yeah, okay. So these two situations will give us the product of hydrogen and oxygen. So that's the idea. Okay, final question. Give the name of substance Z that may be. Okay, how about substance Z? Okay, so Z, okay, so we are saying that is this ionic compound. Okay, and then it produces a pink brown metal and oxygen. Okay, so this comes from experience. As soon as we get a pink brown metal, it must be copper. Yeah, okay, it must be copper. So our answer is copper oxide. Yeah, so Z is copper oxide. So this one, Z is copper oxide. Okay, so we'll see why. Okay, so copper oxide. So let's say we have copper oxide molten. It can be both case. Okay, so let's say it's copper oxide molten. So we have copper and then we have oxygen. Okay, so we can analyze it. Okay, and okay, let me do both. Okay, so I do both. It's easier to understand. Okay, let me just do both. Okay, Okay, so Z. Okay, so we are saying that this Z is copper oxide. Okay, so we are saying that it's copper oxide. So we'll do two situation. A Okay, actually we'll do molten only because aqueous, normally we don't do aqueous because copper oxide is not soluble. It's not soluble in water. Okay, so we'll do the molten situation only. So we have copper 2 plus and then oxide. Okay, now, so this is our setup. Okay, cathode. Okay, anode. Okay, so cathode will attract the copper 2 plus. So copper 2 plus will plus 2 electron to form copper metal. Yeah, so that's how we get this pink brown metal. So that's how we get it. And then at the anode side, we attract the negative ion. Okay, so this oxygen, it will lose electrons to form O2. Okay, so one O2, it will lose 2 electrons to form the O. So 2 O2 will lost 4 electrons to form O2. So we want to form the O2. So negative move to the other side. So we have 2 O2 and then oxygen plus 4 electrons. Yeah, okay. So we get oxygen on the other side. So that's how we get the oxygen here. Okay. So that's why we are saying that Z is copper oxide. Okay. Next. Okay. Complete the table. So again, we need to do analysis. Okay. So as I mentioned before, basically for this topic, you just need to know how to analyze all of the electrodes. Okay. So if you know how to analyze it properly, so you will get the correct answer. Okay, so now again, we will go through one by one. Okay. Okay, so first one, we have molten lead chloride. Okay, molten lead chloride. Okay, let me just erase. Okay, molten lead chloride. Okay, so how do we analyze this situation? Okay, this one also. Okay, so if we have molten lead chloride, okay, so how we analyze it? Okay, lead chloride is like this, okay? Lead is Pb 2 plus, chloride is negative. Yeah, okay. So now it's like this. Okay. Okay. Cathode, okay. And then here, anode. Okay. So the lead, so molten, no water. So the lead will be attracted to here. Okay. Yeah. Pb 2 plus, it will plus 2 electrons to form the yeah, so this one is carbon electrode, carbon, okay, no problem. Okay, to form the lead metal, okay, just like that. So at the cathode, we will have the lead metal. Yeah, okay, so just the lead metal. And then at the anode, it will attract the chloride. Yeah, okay. So what happened to chloride? So chloride, it will be adding 2 electrons to form the it will be removing 2 electrons, okay? Removing 2 electrons to form the chlorine gas, okay? So here we have chlorine, okay? Our product here. Okay, second situation, okay? So second situation, if we have platinum electrode, if we have hydrogen, if we have oxygen. Okay, this one, if we see this, is always sulfuric acid. Okay, so actually it is electrolysis of water. Okay, this situation is actually electrolysis of water, but we put sulfuric acid. Why? Because the sulfuric acid will help to there will be more ions if we put sulfuric acid, so the conductivity will be higher, so it will have a better conductivity. So this situation, the real situation, we are doing electrolysis of water, but we add dilute sulfuric acid a little bit to increase the conductivity, so the reaction is faster. Okay, so now this situation, we have the sulfuric acid, we have H plus, and then we have sulfate, and then from water we have H plus, and then we have the hydroxide. Okay, again, we analyze. Okay, okay, cathode. Okay, and then this one is anode. Okay, platinum, platinum electrode is inert. Okay, no problem. So now here is H plus, H plus, so both will react. So now we have H plus, two of them, plus two electrons from the hydrogen gas. Okay, so that's why we have this hydrogen gas here. Okay, next, the other side, we have sulfate and hydroxide. Yes. Okay, sulfate and hydroxide. Okay, so at any point you are not sure, confused, you just stop me and ask. Okay, so here we have sulfate and hydroxide, always hydroxide, because sulfate is very stable. Okay, so hydroxide, we have for hydroxide, it will turn to oxygen, water, and 4 electrons. Okay, so our product is oxygen here. So that's why we have oxygen. Okay. Okay, next. Okay, we have molten calcium bromide. Molten means no water. So means we have um, um, calcium. Okay, bromide like this. Calcium is group 2, so it's always 2 plus. Bromide is -1. Okay, so molten calcium bromide, normally we will just use inert electrode. Normally we just use a carbon electrode. Okay, so now, okay, how it happened? Okay, okay, cathode, anode. Okay, so negative will attract positive. Okay, and then this positive will attract negative. Yes. Okay, so now this calcium will plus 2 electron to form calcium metal. Okay, so here at the cathode we will have calcium. Okay, calcium metal. Okay, and then on the other side, the bromide, again, it will lose 2 electron to form the bromine gas. Okay, so our product is bromine on the other side. Okay, yes. Okay, so here, the fourth situation, we have sodium and chlorine. Okay, so as soon as we see sodium here, we know it must be molten. Okay, it cannot be aqueous. It cannot be aqueous, because if aqueous, it will have hydrogen at the product. Okay, so as soon as we see sodium, it must be molten. And then we have sodium and chlorine, so means we have molten sodium chloride. Okay, and then normally this situation will use carbon electrode. Okay, inert electrode. Okay, so how it happened? Okay, so like this. Okay, molten sodium chloride. So we have sodium plus, chloride negative. Okay. Okay. Cathode negative. Okay. Positive, anode. Okay. So the negative will attract the positive, which is the sodium plus. Okay. So here the positive will attract the negative, which is the chloride. Okay. Yes. Okay. So the sodium, what happened? Plus one electron to turn to sodium metal. So that's why we have this sodium metal here. Okay, so this chloride, okay, again, it will lose two electrons, okay, to get this chlorine gas. So that's why we have this chlorine gas. Okay, so that's how it works. Okay, next. Okay, okay, so here we have fill in the blanks. Okay, what is electroplating? Okay, we know that. Electroplating is the process that uses electrolysis to plate or coat one metal with another. Okay, so let's say we have a metal spoon. We need to coat it with another metal. Okay, so the purpose of electroplating is to give a protective coating. Okay, to protect the surface of that is underneath. Okay, for example, bath tap. Okay, bath tap in the toilet, they are chromium plated. Okay, to prevent. Okay, so in our toilet, our water tap is always um, plated to prevent corrosion. Yeah. And at the same time, they are given a shiny, more attractive finish. Yeah, okay. So it becomes shiny. Electroplating process is carried out in how we carry out in a cell. Okay, electrolysis cell. Okay, this is often known as the plating bath, and it contains a suitable um, suitable electrolyte. Okay, usually a solution of a metal salt. Okay, so it depends. If we want to coat with silver, we will put a silver salt. Okay, so yeah, so this is our setup like this. Okay, so let's say we want to plating the spoon. Okay, we will put the spoon there. Yes, we'll put the spoon at the cathode. Okay, and then let's say we want to plating silver. We'll put the silver at the anode. Okay, like this. And then the electrolyte we will put silver nitrate. Okay, for example. Okay, the electrolyte. Okay, for silver plating, electrolyte solution will be a silver salt. Yeah, silver nitrate. The article to be plated is made the cathode. So what we want to plate is made the cathode. Okay, so that the ions will move to it when the current is switched on. Okay, so when the current is switched on, so we will have like this silver plus electron to form the silver metal. Okay, so that's how it happened. Okay, next. Okay, electrolysis of water. So just now we mentioned electrolysis of water is like this. Yeah, okay, this one. Okay, so this one, a Hoffman water meter. This is a Hoffman water meter, okay, to do the electrolysis of water. Okay, why we need this? Because we need to collect the gas. Okay, oxygen here and then hydrogen here. Okay, so this will let us collect the gas. Okay, it's essential to add a little bit of dilute sulfuric acid. Okay, so what we mentioned just now, we will add a little bit of dilute sulfuric acid. Okay, why we do that? As we mentioned just now, increase the conductivity of water So there are more ions, so the electrolysis will be faster. Okay, next. Industrial electrolysis of concentrated sodium chloride solution is necessary to keep the chlorine gas and sodium hydroxide separated. Okay, so this one, okay, let's see whether we have in the notes or not. Okay. A okay. Okay, it's not really in the notes. It's not too important, but I can explain now. Okay, so let me explain. Um, okay. Yes. So this is another notes that is a little bit more detailed. Okay, let me find. Ah, yes. Okay. So this is electrolysis of the concentrated sodium chloride solution. Okay. So we see here uh to keep the chlorine gas and sodium hydroxide separated. Yeah, okay. So you see the chlorine gas is produced here, the sodium hydroxide solution is produced here, and then it is separated. Yeah, okay. So why we do that? Okay, let's take a look. Okay, because they will react together and the products would not be as wanted. Okay, so we want to separate them so they do not react together. Okay, so let us see how it happened. Okay, so concentrated sodium chloride. So we have sodium plus chloride negative, and then we have water, hydrogen, ion, and hydroxide. Okay, so what happened here? We have this cathode. Okay, it will attract the sodium plus, hydrogen plus. Okay, so now as we know, the hydrogen is the one that will react. Okay, so hydrogen plus 2 electron. Okay, it turns to hydrogen gas. So this is our product here, hydrogen gas. And then here we have chloride and hydroxide. Yeah, okay. So now, um, because it is concentrated, the chloride will react. Okay, chloride, okay, turn to chlorine, removing 2 electrons. Okay, so this is how we have the chlorine gas. Okay, so in the end, we are left with hydroxide and sodium, which is removed from here. Okay, so this is the concept for this question. Okay, yep. Okay, next, electrolysis of lead bromide. The lead bromide should be in the molten state. Okay, yeah. So why we want the molten state? Because we want it to conduct electricity. Yeah, okay. So the ions will be mobile in the liquid. The ions can move, so it will conduct electricity. Then only the electrolysis can happen. Okay, next. Oh yeah. So this one, we want to practice the ionic half equation. Okay. So ionic half equation. So now we are going from sodium plus to sodium zero. Okay, so sodium plus is like this. Okay, so no electron, and then we go to sodium zero. Okay, so we are adding 1 electron there. Okay, so basically we are adding 1 electron. Yeah, okay, like this. Okay, next. This one, bromide. Okay, so bromide. Okay, okay, it has 8 outer electrons. Yeah, okay. it has 8 outer electron, okay? Return back to the bromine, okay, atom, which is having 7 outer electrons only. So it will basically minus 2 electron, okay? It minus 2 electron, but it moved to the other side, okay? So basically it minus 1 electron, but because we have 2 of them, it will minus 2 electrons, okay? To get the Br2, okay? Okay, like this. Okay, next. Calcium 2 plus will turn to calcium metal. So from 2 plus to 0, we will plus 2 electrons. Okay? Yes. Okay. Next. Okay, copper, metal, it must be always starting copper 2 plus. Okay? Adding 2 electrons to give the copper metal. Yeah, okay? So hopefully it's not confusing. If anything, you just stop me, okay? To ask questions. Okay. So this one iodide, okay? Iodide is always turned to iodine, okay? So that's the stable form. 2 iodide, 2 electron, okay? So this one is losing 2 electrons to form the iodine, okay? Like this. Okay. Next, hydroxide, okay? As mentioned before, always like this. We start with 4 hydroxide and then 2 water, 1 oxygen, and 4 electron. Okay, always like this. Can memorize. Okay, yep. Okay, electrolysis. Okay, so this one, yeah. Okay, so what is going on here? We have electrolyte. Okay, electrolyte of sodium chloride. Okay, platinum electrodes. Okay, and not cathode. Okay, so we see this is chlorine here. The product is chlorine. Okay, so we have two situations. Okay, we can have two situations. Okay, let me show. Okay, okay, let me show two situations. Okay, so this one it just say sodium chloride. Okay, it does not give any information. We can have dilute sodium chloride. Okay, and then we can have um okay, concentrated. Okay, concentrated sodium chloride. Okay, what's the difference? Okay, so this one, the chloride is less. Less. This one, the chloride is more. So that's the difference. Okay. Okay, now we have 4 ions, sodium, chloride, and from water, like this. Yes. Okay. So now, and then we have the cathode, anode, okay, cathode, anode. Okay. So now, same as before, sodium and hydrogen will come here next to the negative. Sodium and hydrogen will come here at the negative, and then chloride and hydroxide will come here. Okay, chloride and hydroxide. Okay, so now here is always hydrogen, always, because sodium is very reactive. It cannot react. So here is always hydrogen. So this side, the product is always hydrogen. 2 plus 2 electron to form hydrogen gas. Okay. So the product is always the same on this side. Okay. So on the other side, here, the dilute one, we will take hydroxide. Here, it will take chloride. Always like that. Okay. This one, less chloride, so we will take this one. This one, more chloride, we will take this one. Okay, now this one, the product will be 4 hydroxide turn to oxygen, turn to water, turn to electron. So the product will be oxygen. Okay. This one will be 2 chloride. Okay. Turn to chlorine gas like this. Okay. So this product will be chlorine. Yeah. Okay. So we can see here the product here. This is oxygen. This is chlorine. That's the difference. Okay. But here, it's just the same. Okay. This side is the same. So that's how we analyze this situation. Okay. So here we see that this product is hydrogen, no problem. We know that this is always hydrogen. Okay. But here, this is chlorine. This is chlorine, which means this is concentrated. Yeah, okay. This concentrated sodium chloride. Okay, so that's how we know. Okay, next we can look at the question. Okay, balance the following equation. Yeah, we already done that here. Okay, 2 hydrogen ion plus 2 electrons, it turns to hydrogen gas. Okay, next. Okay, chlorine is produced at the anode. Okay, how to do the half equation? So we did that just now. Here. Yeah, okay. So it's 2 chloride. Okay, remove 2 electrons to give the chlorine gas. Okay, yep. Okay, so this is the overall chemical equation. What is happening? Okay. Oh, now is chemical calculations. Okay, so if we put 234 grams of sodium chloride, calculate the mass of each of the following substances that would be formed. Okay, showing your working. Okay, this is very good. We can practice the chemical calculations. Okay, yeah. So we can copy this. Okay, and then like this. Okay, so we done the chemical calculation in the last topic. Okay, so hopefully still can remember. Okay. Okay. So our basic concept of the chemical calculation in the middle is always mole. Yeah. We can start with mass. We can start with uh concentration. Okay. We can start with volume of gas. We can start with anything and then we can get the mole. And then once we get the mole, we can calculate back the mass, and then we can calculate the concentration, and then we can calculate the volume of gas. Okay, so the formula is different for each one. So for this one, we just focus on the mass for this question. We start with mass and then we end with mass. Okay. All right. So this one sodium chloride, we start with mass of 234 grams. Okay, so if we know the MR, if we know the MR, we can get the mole. Yeah, okay. So if we know the MR, we can get the mole. And then once we get the mole, we can get this. Okay, we can get this mole. Okay. And then we can work out the MR. Okay. Okay. And then we can get the mass. That is our final answer that we want. Okay. So we are saying that if we put here 233 grams of sodium chloride, how many grams of sodium hydroxide, how many grams of chlorine, how many grams of hydrogen can we get? Okay, so that is the concept of this question. Okay, so first MR of sodium chloride is 1 sodium plus 1 chloride, that is equal to sodium is 23, 35.5, 23, 35.5, this is 58.5. Okay. Yeah. Okay, so this one sodium chloride is sodium 23 plus oxygen 16 plus hydrogen 1. Okay, so that will give us 23 plus 16 plus 1. Okay, so this is 40. Okay, 40. Okay, so Cl2 is chlorine, 2 times chlorine. 35.5 times 2 is 71. So this is 71. Okay, so hydrogen is 2 hydrogen, 1 plus 1. So this is 2. Okay, so now we have the MR for everything. Yeah. So once we know what we want, we can just do it by batch. Okay, so MR is 58.5, MR is 40, MR is 71, MR is 2. Okay, so now we will work out the mole. Okay, so this 1 mole, okay, always remember MR equals to mass divided by mole. Yeah, okay. MR equals to mass divided by mole. So now we want the mole, okay, mass divided by MR. Okay, mass is 234, MR is 58.5. Okay, so we calculate that. Okay, so this is 4. Okay, so this is 4 mole. Okay, now we can see this is the mole ratio. Okay, okay, the mole ratio is 2, 2, 2, 1, 1. Yeah, 2, 2, 2, 1, 1. Okay. Uh, let me find a space. Okay. Okay, let me find a space. Okay. Um, sodium chloride. Okay. Uh, sodium hydroxide. Okay. Chlorine, hydrogen. Okay, so this is 2, 2, 1, 1. Yeah, okay. So 2, 2, 1, 1. Okay, so if we simplify it, is 1, 1, 0 0.5, 0 0.5, like this. Okay. Okay, so now this is 4. This is 4. This is same. This is 2. This is 2. Yeah, okay. So it just divided by 2. Okay, so if this is 4 mole, this will be 4, 2, 2. Okay, just like that. Okay, let me find another color. Okay, so now we settle the mole. Okay, so the mole is 4. Okay, let me find another color. Okay, yes. Okay, this is 4. This is 4. This is 2. This is 2. Okay, so finally, to find the mass, okay, so to find the mass equals to MR multiplied by mole. Okay, so this one, it will be MR multiplied by mole. So this one will be 40 multiplied by 4. 160 grams. Okay. And then this one will be 71 multiplied by 2. It will be 142. Okay. Grams. And then this one is 2 times 2. Yeah. 2 times 2. This is 4 grams. Okay. So now in the final step, we get all of the answers. Okay. At one go. So if we understand the concept, it is straightforward. Okay. Yeah. So we just need to recall our mole concept. Okay. So if we do everything correctly, we'll get the correct answer. Yeah. Okay. Yep. Okay. So we'll get the product. Sodium hydroxide will be 160 grams. Chlorine, okay, 142 grams. And hydrogen, 4 grams. Okay. And okay. Still have time. Let's do another. Okay. Okay. This one is a long question, so maybe we don't have enough time to finish it. Okay, so maybe we can continue tomorrow. So tomorrow, as usual, we will start at 8:30. Okay, so if you want to change the time, anything, or if you want to change the class, anything, you just let me know. Okay, so otherwise we will start as usual. Okay, we'll start as usual of 8:30 tomorrow morning. Okay, tomorrow is Friday. So yeah, so this one is still in progress. Tomorrow we will continue. Okay, so if no other question, we will stop here. Okay, all right. Thank you. Thank you. Bye bye.